Now, y'all read about the conoid of Sturm and the circle of least confusion. This is a conoid of Sturm. The toric lenses, if you have a toric lens with power in both meridians, and it's a plus lens, much easier to envision, it makes one line of parallel light here, and 90 degrees away, another parallel beam of light. And in the middle, there is a circle called the circle of least confusion. So this is a conoid of Sturm, elegant. And then in real life, what the lens does, this is two sills taped together. Actually, it's a +5 sphere and a +5 sill. And it makes two focal points. One is at the +5 power meridian, so about 20 centimeters away from the wall. And then the other, +5 + 5 equals +10. So at about 10 centimeters away from the wall, there's the other meridian. So this is one end of the conoid of Sturm. This is the other. And in the middle is the circle of least confusion. And that circle of least confusion is the dioptric center of this. It's not halfway between 10 centimeters and 20 centimeters. It's not at 15 centimeters. It's halfway between 5 and 10, that's 750. And then you flip that upside down and figure out the focal distance of that, which is like, I don't know what, 13. I've got it written right there. So let's do this with two lenses. Here we have one meridian, the other meridian, circle of least confusion. This is a +750 lens. You can see when I hold, if I can hold these parallel, which I'm having a hard time doing, where I get the circle of least confusion in focus is where the +750 is in focus. At this meridian, the 750 is out of focus. At that meridian, the 750 is out of focus, but where the circle of least confusion is, mathematically should be and is at +750. So the circle of least confusion is where the conoid of Sturm is the most round. So if an uncorrected patient is accommodating through this amount of astigmatism, they're going to try to put that circle of least confusion on their retina because they'll have the best image. Maybe if they're looking at something that's vertical, they might accommodate and let that meridian be closest to the retina. It'll look a little sharper. Or if they're looking at something that's more horizontal, they might accommodate to let that meridian be on the retina. But in general, they're going to have the best overall vision when they get that circle of least confusion on the retina. So that's that. And we use it a lot in contact lenses and in refraction.